So we've been talking about measures of center and measures of variation, looking at how we calculate some of those statistics. We are going to continue with measures of variation today and talk about standard deviation and variance. Two more types of statistics that help us determine how spread out our data is. All right, so standard deviation is a measure of how far the numbers in a data set deviate from the mean. In the previous lesson, we studied range and interquartile range. Each of these is a measure of variation. Measure of variation describes how the data in a data set are spread out. So our two new terms, variance and standard deviation, are measures showing how much the data values deviate from the mean. We use the Greek letter sigma. Now, just like in our alphabet, they have lowercase and uppercase letters. Okay, this is the lowercase letter sigma. Basically, we do that. A vertical bar and then kind of swing around over top of it. Okay? Oftentimes, there will be an X next to it. So that is what we use for standard deviation. And then if we take that value and we square it, so sigma squared will give us variance. Okay, now, how we technically calculate variance and standard deviation. We start out, we find the average of our values. So we take our data set, we find our average. Okay? Then we are going to take every single value in our data set. We are going to subtract the mean from it. Okay, so we're going to take our data points, we're going to subtract the mean, and then we are going to square that number. We are going to do that for every single value in our data. Okay? Then we add up all those answers. So this is the uppercase Greek letter sigma, means summation. Right? We're going to sum all of those numbers up. We're going to divide by the number of items in our list. And that is sigma squared. That's our variance. Then if we square root it, we get down to our standard deviation. That's a lot of work. Yes? Especially if your set of data has more than 5 or 6 numbers, it can be time consuming. So we are going to be efficient. We're going to use our calculators. Remember yesterday when we entered data in a list and then we went to stat calc, one variable statistics, right? And we saw a whole bunch of statistics. We kind of glossed over the ones we're going to talk about today. All right, so grab your calculators. For our first example here, it says the table displays the number of U.S. hurricane strikes by decade from the years 1851 to 2000. What are the mean and standard deviation for this data set? Now we have 2 rows of numbers here, but the top number is just giving us the decade, okay? So we started in 1851, go out 10 years, right? So this would be 1861. Okay, so we don't need the top row of numbers. We're just looking at the strikes, hurricane strikes. Okay, so I'm going to pause the recording for a minute. I want you to enter all the numbers in that lower row into list 1. All right, so we are going to go, we've entered all of our lists in list 1. We're now going to go to stat over to calc. We're going to choose one variable, statistics, and it is telling me that's going to default to list 1. So if you're always putting everything in list 1, you don't have to change this. But remember, you can, if you entered your numbers in a different list, you can always do second and whatever the number is for your list. Okay? Go down to calculate, and we've got our statistics. So what were they asking us to find? The mean and the standard deviation, okay? So when you look at that screen, our mean is the first one, right? X bar. So we would say our mean is about 17.6. And then our standard deviation is this one, the one that has that sigma next to the X. So in this case, our standard deviation we would say is about 3.5. Okay? All right, so I want you to try that again. I'm going to pause the recording again. This time you are entering the lower row of numbers. You can just put them back in list 1 again if you want. We are asked to find the mean and standard deviation again. All right, we are going to use this data later on in class, so I do want to make sure we have correct answers here. What did we get for average or mean? 7 point. Okay, and standard deviation. Okay, so when you're asked to find these values, I would go out to hundredths place. Later on, we're going to round them a little bit for an activity, but in general, when you list them, I would go out to hundredths. All right, so how do we find the variance if we know the standard deviation? Yeah, we just square it. So if we know our sigma value, we can square it to get our variance. So in this last example, our variance would be 3.21 squared. What do we get? 10.30. All right, any questions on using the calculator to find standard deviation? All right. It says, use the U.S. hurricane strike data from problem 2. Within how many standard deviations from the mean do all of the values fall? Now, just to be clear, we need to go back to the first example we used. Okay, so you're going to have to flip back a page. The first number in your list should be 19. Everybody see the chart I'm talking about? Okay. What we are going to do is we are going to make a little number plot. What was the lowest and highest value from that list? There's a 24 for high. Was there a 12? Okay, so our number line needs to make sure we can include the 12 to 24. So I would probably go maybe from 10 to 26 just to have a little leeway. Okay, so we're going to draw a number line. Evenly spaced tick marks, I'm going to go by 2s. Okay, and what we're going to do for each value in our list, we're going to put a little X above the number line. All right, so go to our list. Our first number is a 19. 19 would be halfway between 18 and 20. We're going to put a little X there. Okay, then our next number is a 15, 20, 22, 21, 18, and 21, 13, 19, 24, 17, 14, 12, 15, and 14. All right, so it is another way we can see mode. We can see how many, how tall each little section of our graph gets. What we're going to do now is we're going to divide that wherever our average is. Okay, so what was the average from this data? What was our average from this first one? 17.6? All right, and what was the standard deviation? 3.5? So for this type of activity, I'm fine with you just going out to tenths. All right. What we're going to do is we're going to chop up our graph. We're going to start by dropping a line at 17.6. And I'm going to label that the average. And then we are simply going to add and subtract our standard deviation from that. Okay? So I'm going to go up. I'm going to add 3.5 to that. What's 17.6 plus 3.5? 21.1. So we are just to the right of these values at 21. Yes? So 21.1 is one standard deviation above the mean. Okay? We are going to continue doing that. We're going to keep adding the standard deviation until we run out of x's, right? We have to get beyond all of our x's. So I'm going to go through and add another 3.5 to my 21.1. So I'm at 24.6. Have I gotten past my x's? Yes. This one is 2 standard deviations above the mean. Okay? So I can stop on that end because I've already gotten to the right of all my x's. Now I'm going to go to the other side, and now I'm going to subtract standard deviations until I get to the low end. Okay? So I'm going to go from 17.6, I'm going to subtract 3.5. What's 17.6 minus 3.5? Okay, so I need to drop a line here at 14.1. And that is 1 standard deviation below the mean. So I'm going to write that as -1 sigma. Okay, I'm 1 standard deviation below. And I'm going to do that again. Subtract 3.5 from our 14.1, and we end up at 10.6. Okay, and that is 2 standard deviations below the mean. Okay, so I can go 2 standard deviations above, 2 standard deviations below, and I've included all of my data values. Does that make sense? So the question was, within how many standard deviations of the mean is all of your data? We would say within all data is within 2 standard deviations of the mean. All right, I'm going to pause the recording. I want you guys to try the second example here. So you're going back and using the Atlantic Ocean from 1992 to 2006 data, that second chart that we looked at. All right, checking your work. Does it look like I've got the x's in the right spot? Does it look like yours? Okay, so our average here was 7.3. We added our standard deviation of 3.2, right? We went up in increments, and we subtracted on this end. Okay, subtracted that 3.2. Now, we have to keep going, doing this until we've gotten past all of our x's, all of our data. So on the upper side, we had to go out to 3 standard deviations. Yes? And on the lower side, we only had to go to 2, -2. We would still go to that biggest number. So I can't say my data is within 2 standard deviations because on the right-hand side, there's still that one value at 14 that I have to get past. Does that make sense? So I'm going to have to say all of my data lands within 3 standard deviations. You have to go with the farthest one. Okay? All right, any questions on that? All right. Going to do just a quick check. Find the mean, variance, and standard deviation for the data set. Do you know what to do for that? Could you enter that in a list and go to your one variable stats? Okay, we're going to skip question 1. I do want you to do question 2. Within how many standard deviations of the mean is all of that data? So take a minute, enter it in your list again, find your mean and standard deviation, and make your number plot. All right, your number plot should look like that. What did you end up with for an average or mean? 13? All right, so we've got our average here. Standard deviation was 2.76. All right, we'll use about 2.8 for our calculations here. So 13 plus 2.8, we'd be at 15.8. That's one standard deviation above. Add another 2.8, and we're at 18.6. So is that far enough? Okay, we've passed all of our data on that end. Subtracting 2.8 from 13 would give us 10.2. That's -1 standard deviations. Subtracting another 2.8 would be 7.4. Is that far enough? Okay, so we would say all of our data lands within 2 standard deviations of the mean. Yep. All right. The next question says, explain the difference between measures of central tendency and measures of variation. What do we mean when we say measures of central tendency? Mean, median, and mode, right? We're trying to measure the center, yes? Central tendency. We're trying to look at some center values, okay? So mean, median, and mode. What about measures of variation? Yes, how far our data is spread out, okay? Measure of spread. What are some of our measures of variation? Range, interquartile range, quartiles, yep, which helps us find the interquartile range. What did we just talk about today? Standard deviation and variance, right? All of those just talk about how spread out the data is. Question 4 says, compare and contrast 3 data sets. Each have a mean of 70. Okay, so I have 3 different sets of numbers, but their averages all come out to be 70. Set A has a standard deviation of 10, set B has a standard deviation of 5, and set C has a standard deviation of 20. Compare and contrast those 3 sets. Which set of data is most compact, the least spread out? The one that has a standard deviation of 5, so set B, okay? So set B is the most compact, or least spread out. Okay, what would be next? If we're going from the least spread out to the most spread out. Set A would be next, and then set C would be the most spread out. Okay. Last question. What is the effect of an outlier on the standard deviation of a data set? So the other day we talked about whether we should count outliers in our data or not, use them in our calculations of our statistics or not. Would having an outlier affect the standard deviation? Yes, because the standard deviation is saying how far is my data spread out from the mean. The more spread out it is, the bigger my standard deviation is. Yes? So it definitely would affect that. So again, it's always a good idea to look at the type of data you have and determine, does an outlier make sense to consider, or should we eliminate it from our list of numbers? Okay, but yes, it would affect, an outlier would affect your standard deviation. All right, so are you able to find and apply standard deviation and variance? So do we know how to get that from our calculator? Which of those two terms can you see right on your calculator? The standard deviation. To find the variance, you have to square it. Yep. All right. And then using the standard deviation to figure out how spread out the data is. How many standard deviations do we have to go out to fit it all? All right. So you guys are going to do page 715. The last two here, the 28 and 29, I want you to do those by hand. Okay, it's a box and whisker plot. Make sure you have a nice, accurate number line for it.